Hello. Today we're going to be talking about writing chemical reactions from words. And there's two real things that we need to be familiar with to be able to do this. The first is going to be formulas. And the second is going to be symbols that we need to use. For the most part, for formulas, most of the formulas you're going to run into are going to be ionic. There are very few covalent that you'll run into in this level of chemistry. If it is an ionic formula, there are two things that you need to consider. You need to pay attention to the charges. Ionic compounds form by a positive and negative charge coming together, so you need to use a periodic table to find those charges to help write the formula. The second thing you need to pay attention to is going to be your endings. With ionic formulas, the "ide" ending is usually a single nonmetal, but "ite" and "ate" are polyatomics. The second thing about formulas that you need to be careful of is elements. We've used ions, we've used subscripts, but when we're talking about an element, your elements, for the most part, are just going to be the symbol only. In a chemical reaction, they are not generally ions, so they're not going to have a charge. So if I'm going to write a formula for sodium, it's just the Na. There is, however, an exception to this, and this exception happens very commonly. The exceptions are going to be your diatomics. On the periodic table, there are 7 elements that always come paired as 2s. The rule I use for this is going to be H, N, 7. H referring to hydrogen because hydrogen sits off by itself. Hydrogen is always going to be an H2. N referring to nitrogen because that becomes your starting place, and that's N2. And then on your periodic table, you literally make the shape of a 7. And that will include oxygen, fluorine, chlorine, bromine, and iodine, which are the remaining elements that are going to be diatomic. Now for symbols, there are tons of symbols that are used in writing chemical reactions, but we're going to keep it basic and simple. For our purposes today, we're going to look at a plus sign, and a plus sign is going to separate 2 or more things on the same side of the equation. Keywords that you're going to be looking at are and, reacts with, and there are some others that you will run into. Second symbol that we're going to be paying attention to today is going to be an arrow, and that's going to separate your ingredients from what you're producing. In chemistry, we call those reactants, so your starting materials. From your products, which are going to be your ending materials. Keywords are going to be to form or produces. Sometimes you'll see the word yields. So let's take a look at an example of this. Zinc and lead 2 nitrate react to form zinc nitrate and lead. So I have multiple parts to this equation. I have zinc. And what do I know about zinc? Zinc's by itself, and zinc is going to be an element. For an element, we said elements are just a symbol, and zinc is just a symbol. At this point, zinc does not have a +2 charge, so it's not okay to put the charge up there, and it's not part of my diatomics, so it doesn't have a subscript, and is going to become my plus sign. And then it's going to say lead 2 nitrate. Now you need to be careful that you're reading completely, because this becomes a compound. Now most of my compounds are ionic, and it is. And if I use my periodic table, I find that lead can be a 2 or lead can be a 4, but the whole purpose of my Roman numeral is to tell me that lead is a 2. I also have to pay attention to my endings, because this is an 8 ending. So this is going to be a polyatomic nitrate, which is going to be NO3, which has its own charge, but its own charge is going to be a 1. And those charges are going to switch. So this is going to be PB. I have to put NO3 in parentheses with the 2 on the outside. Now it says react to form. And react to form is going to be the symbol for my arrow. It's going to form zinc nitrate. Now what you're going to find with a chemical reaction is I take these and I scramble them up, and it's what's going to be in my product side. So this time I'm going to have zinc, but it's going to be with nitrate. Well, I still need to take a look at charges. So zinc on my periodic table says zinc is going to be a 2 for a charge. Nitrate is still nitrate. I still have to pay attention to my endings. So it's still the NO3 that I started with. It just has a new partner. And nitrate's going to remain the 1- charge. And what happens? Those charges switch. So nitrate again goes in parentheses with the 2 on the outside. And it's going to be another plus sign. And this time it's going to be lead. But this time lead is an element. And as an element, it's just a symbol. It doesn't need anything to go along with it. So there's my equation. The last step in my equation is always going to be to make sure that my equation is balanced. But this equation comes pre-balanced because I have 1 zinc and 1 zinc. I have 1 lead and 1 lead. And each side has 2 nitrates. So this equation already comes out pre-balanced. So let's try one more. Aluminum bromide and chlorine gas react to form aluminum chloride and bromine gas. So I have aluminum bromide, and aluminum bromide is a compound. And if most of my compounds are ionic, it is. And with an ionic compound, I have to pay attention to my charges. So aluminum has a 3+ charge. And my endings, so bromide is just going to be bromine. That has its own charge. It's going to be a 1- charge. Those charges are going to switch, so the 3 from aluminum is going to go to bromine. And I don't care about the 1, so it's going to be AlBr3. And is going to be my plus sign. Now this is chlorine gas. And the gas part just tells me its state of matter. It's not a liquid, it's not a solid, it's a gas. We will get to symbols in another video. But if I'm talking about chlorine as an element, I have to remember my diatomics. Those 7 elements that we talked about up here come up really commonly. And when I write those 7 elements, I am always going to make sure that I'm going to write a 2 beside it as a subscript. So as an element, chlorine is going to be Cl2. It is going to react to form, which is going to be my arrow. and it is going to react to form. Be careful that you read completely. It's aluminum, but follow on to the next line, aluminum chloride. So now I have a compound. Well, aluminum is still the 3+ charge. And I still have chlorine. But here's an important, almost common mistake. Yes, chlorine has a 2 here. But in a compound, chlorine is a halogen that has a 1- charge. And when I'm writing a formula, those 2's from the element state go away. So these charges are going to cross, and aluminum's a 3, chlorine's a 1, so chlorine's going to get the 3 from aluminum. Yes, it looks very similar to the formula for aluminum bromide. And I'm going to have bromine gas. Again, gas just gives me the state of matter. I'm not worried about that right now. I'm going to write the symbol for the element bromine. But just like chlorine and most of my halogens, bromine is also going to be a diatomic, so that when I write it as an element, remember compound is -1, but as an element, this is going to be Br2. Now, last step in this equation is to balance the equation. And if I'm going to balance the equation, I need to make sure that I've got the same number on both sides. So 1 aluminum and 1 aluminum, and that works good. But I have 3 bromine and 2 bromine, and I'm going to need a common number for those, and that common number is 6. So to balance the equation, I'm going to need to put a 2 here, which is going to give me 6, and a 3 here, which is going to give me 6, so that my bromine is balanced. That, of course, changes my aluminum, so I can put a 2 here, and now I have to balance my chlorine. Well, if I have 6 on this side, I can put a 3 over here to have 6 on this side. Now it's your turn. Pause the video and try the next 2 problems. And as you're trying the next 2 problems, then check back. Good luck. So, check your answers. How did you do? Again, when I'm writing a compound, it is really important that I pay attention to the charges and to the endings. So I have sodium phosphate and calcium chloride. And then always really, really important that you're making sure that you balance the equation at the end of the video, or at the end of the problem. In number 4, remember your diatomics. Diatomics are key, and they're a common mistake that students are going to make. So you really want to be careful because you will run into diatomics very frequently. All right, so try a few of these on your own and see how you're going to do.